Boys, today we're looking at prime factors. So if you just think about that heading, prime factors, so far in this topic we have looked at both prime numbers and also factors of a number. So last time you looked at prime numbers and you saw that prime numbers were numbers that only had two factors, so the number itself and one. And then we've looked at factors, and factors are numbers that will go into a number. So we can think of any number in terms of its factors. So like if I've got the number 10, then its factors, the numbers are going to it are 1, 2, and 5. An example, I guess, of a prime would be 13, which only has factors 1 and 13. No other numbers go into it. So we're going to be writing numbers as a product of their prime factors. So if we've thought about what factors are, we can think about numbers that are prime factors, so factors that are prime numbers. And so if we just think about 10 there, well, all its factors are prime, like 2 and 5. Well, 2 and 5 are both prime factors. One's not a prime number, but 2 and 5 are both prime factors. Let's just say we took 12, looked at the factors of that, 1, 12, 2, 6, 3, 4. So what are the prime factors there? Well, we can see that 2 is a prime number and 3 is a prime number. They're the only prime numbers there. And so they're the prime factors. And so we're going to be expressing numbers as a product of prime factors. So let's have a look at this, and we're going to use what's called a factor tree to find the product of prime factors. Okay, so here's an example for you. So it says use a factor tree to write 24 as a product of its primes. So 24, the number 24, we can think about just breaking it up into any two numbers. You didn't have to go with 4 and 6. Like you could have said, well, 24 is the same thing as having 3 and 8. And then you can keep breaking it down further until you only have prime numbers. And so in the first example, after we had 4 and 6, broke it up, we could split 4 into 2 and 2. Now they're both prime, so I have to stop there. And 6 can be broken into 2 and 3, both prime numbers. And so 24 we can express as a multiplication of all of these numbers on the bottom row. And we'll see if you multiply them all together, that equals 24. So 2 times 2 is 4, times 2 is 8, times 3 is 24. And so here's a product of prime factors. And we can write this product of prime factors in index form. And this is in index form there, this last row, because you've collected those 2's into making it 2 cubed. So writing this part as 2 cubed. And now it's as compressed as we can have it, that's an index form. So just to show that that's going to be the case, whatever tree we make, I can't go with 3 anymore, but I can split 8 into 2 and 4. And then, of course, I can split 4 into 2 and 2. And so if I bring down these other numbers down to the bottom, I'm still going to have that same. That's a 3. 3 times 2 times 2 times 2, which is the same as what is over there. Those two things are the same. All right, let's look at a couple more examples. Write the following numbers as a product of their prime factors. So let's take 20 and split it up into 4 and 5. Okay, 4 can be split into 2 and 2, and 5 can't do anything with that. And so writing as a product of prime factors, 20 is equal to 2 times 2 times 5, which I could simplify to make it in index form as 2 squared times by 5. Okay, so that's index form. You might want to write another tree just over here when you're filling out your booklet and see if you get the same thing. So just to double check, 2 times 2 is 4, times 5 is 20. Fantastic. Alrighty, moving on. 64. So 64 we can split into 8 times 8, square number. 8 I can each split into 2 and 4. Split those up again. Well, I can't do anything with that one. 2 and 2. And so in fact, 8 is just 2 times 2 times 2 times 2 times 2. Sorry, 64 is. And so 64 is equal to 2 times 2 times 2 times 2 times 2. Need one more, times 2, which is really just 2 to the power of 6. Let's try another one. Okay, C is 240. 240. We could think about that as, well, it's got a 0 on the end, so I know 10, it's divisible by 10. So 240 could be 24 times by 10. Split that up, 24, we've already done a factor tree for 24. So I could do something similar, 4 and 6. And 10 is 2 and 5. Splitting this up again, that's 2, 2, 2, 3, 2 and 5. Okay, so just quickly covering that again. 4 is split into 2 times 2, 6 is split into 2 times 3, and 2 and 5 are brought down. So 240 is equal to 2 times 2 times 2 times 2 times 3 times 5. Now I've deliberately written that in a different order to what you see down the bottom along there, because I know that I've got those 4 2's, so I can just group them now as 2 to the power of 4 times by 3 times by 5 in index form. Alright, so this is a useful skill because we can actually, by breaking a number down into its prime factors, we can find the highest common factor between two numbers. So if we look at 240 and 64, we can find the highest common factor. Now, we've already done these questions above for the whole factor tree, so we can just write down those product of prime factors. So 64, we saw that that was equal to 2 to the power of 6. And 240, we saw as being 2 to the 4 times by 3 times by 5. So what's the highest common factor between these two? Well, if we find what's in common between these two lines, that's going to give us our highest common factor. So what is contained in both of those? What factors are all in the same? Alrighty, well, if we just write both of them again in the form that we had before, so if we split up this guy into 2 times 2 times 2 times 2 times 2 times 2, and this guy into 2 times 2 times 2 times 2 times 3 times 5. What do they have in common? Well, there's a factor of 2 and another factor of 2 down the bottom, a second one, a third one, and a fourth one. So they both contain 4 factors of 2. And so the highest common factor is going to be equal to 2 times 2 times 2 times 2, or 2 to the 4. Which of course is 16. So 16 is the highest common factor between 64 and 240. And we can find that using the product of prime factors for each of the numbers. Okay, so our main thing today was to be able to express a number as a product of prime factors, and then we can see how to find the highest common factor between two numbers. Good luck with your questions.